This video is a review of Year 8 index laws. So these are the rules that you would learn in Year 8, and I guess you can make them harder in Year 9 and 10, but it's essentially applying the same concept that you learnt as early as Year 8. So hopefully this is solid for you. Let's have a look. Need my draw tool. All right, let's have a look at this first rule. This just says that if you have a to the power of m times a to the power of n, well, what do we do with what do we do with this expression? So I think it's best understood if we gave an example. For example, if you had, sorry, I can't talk at this point in the day, but we'll keep going. If you have d to the power of 3 times d to the power of 4, well, this would be a string over here of 3 d's, but they're being multiplied. D cubed means d times d times d. And d to the power of 4 means 1, 2, 3, 4. So in the end, this string that I have is 1, 2, 3, 4, 5, 6, 7 long. And we're multiplying, so really what we're going to have is d to the power of 7. Okay, sometimes students write 7d, that's wrong, because it isn't d plus d plus d plus d, it's d times d 7 times over. So if you look at that, I'm hoping you'll remember that the quick way to get my powers would be to add them. So a to the m times a to the n is a to the m plus n. Okay. A common error would be to multiply the powers. And a numerical example for that would be something very similar. 3 to the 5 times 3 to the 7 equals. Now, here is where students go wrong. They will often change this number here to 9. And that's wrong because the 9 has a special name. It's called a base. The base is whatever is attached to the power. So whatever is attached to the power is called your base. And if you notice what happens over here, I don't ever change that base. The base starts as D and it ends up as D in my final answer. So that means that whatever my base is, it remains unchanged. So we'll follow our rule of adding the powers and I'll get 12, but the base of 3 does not change. Now you might remember that when we multiply, we add the powers. Well, when we divide, we subtract the powers. So if I had something like d to the power of 5 divided by d squared, the long way would be to write that out as 1, 2, 3, 4, 5 over d squared would be 1, 2. And then, of course, I could cancel, because they're joined by a times sign, I could cancel a d for a d and another d for a d, leaving me with this string of 3, so d times d times d, and that is d cubed. But I really don't want to go through this process every time. That's just a lot of work. What I want to do is go straight to a rule, which is if I have a power of 5 and 2, to get the 3, I can subtract the powers. So a to the m divided by a to the n would be a to the m minus n. Let me repeat what I said before. Your base here is d. Might change mine later. My base here is d, and in the answer, my base is also d. My base does not change. So if I have something like 8 to the power of 9 divided by 8 to the power of 3, that would be 8 to the power of 6. I subtract the powers, but my base does not change. All right. Well, what do I do when I have an expression raised to a power raised to another power? So in this case here, I've got a squared and I need to raise it. I might reduce that power just so I don't have to write it out as many times. I might raise it to the power of, say, 4. Okay, so what that means is I've got to multiply whatever's in that bracket, or this expression here, I'm going to multiply it by itself 4 times. So that would be a squared once, twice, 3 times, 4 times. And if I use what I've learned over here, well, I can just add those powers. So I'm going to get a to the power of 8, but I don't want to do that every time. Okay, these are long methods that I'm going through to remind you of the rule. If I took these two numbers, what would I do to end up with this power over here? Hopefully it's obvious to you that I multiply them. So a to the m, a to the power of m raised to the power of n is really a to the mn, because we will multiply the powers. A numerical example would be 2 to the 7 cubed. Well, we don't change the base, so that base of 2 stays 2, but we do multiply the powers, so we get 21. The last rule that you need to know is anything to the power of 0. Now, do you know what it is? So to do this rule, I think an easy way to look at it would be, say, if I had a cubed divided by a cubed, if I want to use my division rule over here, I'll subtract the powers and I'll get a to the 0. But you should also know that if I took any quantity and I divide it by the same quantity, this a cubed should fit into that a cubed exactly once. And that's why anything to the power of 0 also equals 1. So some nice little easy example would be 6 to the power of 0 equals 1. And an algebraic example, I'll give you a trickier one, is at 3p to the 0. What I want you to notice is you have to pay attention to what's actually being raised to the 0. In this case, what's being raised to the 0 is this p to the 0. It's just p, not the 3p. Notice I don't have brackets. If I have brackets around the 3p and raise it to the 0, then everything in the brackets is being raised to the 0. So these two questions have different answers. This one is the same as writing 3 times 1, because the p to the 0 equals 1. And then when I multiply, 3 times 1 equals 3. But over here, everything in the brackets is being raised to the power of 0. And so 3p all to the power of 0 will equal 1. I hope this video makes sense. It's a quick recap of all those important index law rules from Year 8 that you need to know. In our next video, I'm going to take you through 4 questions where we actually apply them at more of a maybe Year 9, Year 10 level, but it is really Year 8 work.